Okay, hi. This is March 30th, 2025 weekly update. I didn't do as um I had a narrower scope this week, I would say. But so maybe this might be shorter, but I thought I'd throw in some other stuff to talk about that was taking up some of my time. Um, First, with regards to Myl, um, I worked a bit on the Lexer and Parser REPL. Um, let's just see. It looks like I was starting on something, but I just want to show what I was doing. Okay, can I just stash maybe the current changes? ZZ symbol parsing. Okay, and then I will do it. So I don't know if you can see down there. It's like I wish there was just an easier way to just tell CMake to build and run the target, but what I just have it doing is go into the build directory and call CMake and ninja it and run it. It works fine. I could probably make that a script. Oh, so that did the tests. I just want to show the REPL to talk through some stuff. Oh, okay. It's not good. I should not be having compilation errors on my head of my repository. No member name size in parser dot result. Okay, I think this should be um I made it so that the parser returns the vector of s expressions and then an error, which is part of what I want to talk about. So I think I need to make this sexpers. Yeah. And then maybe this will work. Okay. Oh, and I should do that in interactive mode so I can. What in the world? UXPC. Okay. Yes. Okay. So, yeah. So this is the REPL. I think I showed it last time. So, like last time, I still right now only supporting like numbers and like parentheses. But I've hooked it up to the Lexer and parser, so it just prints some stuff out. Like, so I still have these traces, which I should probably remove. But Lex, I could print out the tokens, but didn't have a need at the moment. So I just, okay, parsed 4 tokens, the opening parentheses, the 2 numbers, and the ending parentheses. And then parsed what I parsed it into. So if I do something like a little bit more complex, like that. Let's see if that does it. Yep, so the cons, there's another cons, and it handled the single thing properly by inserting a nil cons. So I'd have that, and that was fine. That was pretty much what we did last week. But part of preparing to do more was integrating better error messages. So I have better error messages. So if I just well, I can actually think of a few ways that it might break, but let me just show you one thing. So, I mean, in the actual language, this is parsed, but I just know for right now I haven't actually handled this. This is handled, the plus is handled in the lexer, but not the parser at the moment. So I know this should throw an error, and we can see it. So yeah. Oh, actually this threw an error in the lexer itself. So the lexer, if you can see, didn't know what to do with that code point. And I just have it right now printing out the line in the column and pointing to it. Actually, I use ChatGPT to sort of guide me in the right direction with like terms of the C++ formatting strings and everything. So let me see if I can get to a parser error. I don't actually know what would cause a parser error. Maybe like this. Yeah, so see, like I was I was saying that I could probably find a way to break it, so I think I just broke it. But yeah, point is I have some better error messaging. And so before I get too far ahead, let me just put this in stage commit Myl bug REPL or handle new parse return type in REPL. Okay. Let me just show you how I did this basically. So in the lexer, I did it really simple. So now instead of just returning a vector of tokens, I returned that and a boolean indicating whether an error was. In terms of the actual process, I just added an error class variable, and when I actually come across an error, like in here, this is the eat token, an unexpected code point that you saw the error for before. All I do is, well, I just emit it in line, so I don't actually like collect a bunch of errors and then emit it. I just emit it in line, and then I set this error flag. And in terms of the actual lexing, as soon as it tries to parse a single token, if it sees that there was an error by looking at that class member variable, it just breaks out, and at the end it'll just return the token. So if there was an error, it'll return like however much it parsed up to that point, and maybe it would give you like a bogus token for the one it couldn't parse. But yeah, that's pretty much how it works. It's pretty dumb, but I just wanted to not crash when I had an error. But that wasn't what I spent most of the time on. That just took a little bit. Most of the time was spent on the VM. And a lot of it was not just code, it was just like trying to reason about it because it was kind of like mind bending to me, honestly. So I referenced that GitHub gist, every VM tutorial you watched is wrong, that I'm really basing it off of on. So I won't go over some of the stuff that he describes there. The one thing that I did want to talk about that I think will touch on a lot of this stuff, though, is the calling convention. So I was settling on a calling convention for this VM. The calling convention. So there's an interesting distinction here, right? Like you'll often hear people say something like the C calling convention. But as far as I understand it, it's not just the language's calling convention. It's not tied to a language. It's tied to a language perhaps, but also to the underlying architecture, the CPU, for instance. It's that combination. So I think when people say like the C calling convention, they mean implicitly like the C calling convention on x86 or whatever platform you're on. And so I think it would be useful because like I didn't really understand this that well, probably still don't, to just talk about what um, what it is in our VM Vesper. So how should I do this? I'll probably have a section for calling convention. So what is really the question here, right? So let's say you have a caller, you have foo, right? I'll just do it in C syntax. Probably can leverage. Yeah. Actually, maybe would be better to have it like this. And let's say we have another function void bar that just calls foo, right? So let's say we're in bar. What do we need to do on the lowest level to call foo? So let's say foo actually takes like int I, int j. Or let's just say int I. And then we'll just say like 2 or something. Or actually, let's do like int x equals 1 and then do x. So what actually happens when we call foo? How does foo know, like on the level of assembly or machine code, where to find x? Right? So the way this works is we have like a stack, right? And like we have slot 1, 2, 3, and like let's say this is, and then here we call foo. What happens? So you can imagine that foo would probably start here right after, and then when it ends, what happens? You could think like, oh, intuitively we pop whatever stack slots were there for foo, and now we're back in bar's call stack frame, and then just keep going with bar's instructions, right? There is a problem though, like how does foo know what parameters are coming in, right? Like we're just on assembly, like you can't, there's no concept of say like a, like, like, where are the inputs coming from? And maybe I should just describe how this happens in the Vesper VM. What we do, and I'm still working this out, right? So right now, for simplicity, what I'm going to say is, when calling a function, the caller places all input parameters, all input arguments at the top of the stack. The callee assumes the input arguments are at the bottom of their stack. So what I'm saying is that, like, right before you call foo, you put the um, you put x at the top of the stack with this instruction called the arg instruction. Basically just puts it at the top of the stack. And then when you're in foo, your stack frame, so this is beginning of foo's stack, I should say bottom. So when you're in foo, you just look at the bottom of your stack, and as we generate the bytecode for foo, having assumed, like, we make assumptions on where the incoming parameters are, how many there are, what types there are. That's all known at bytecode generation time. So the bytecode for foo will know to look at the bottom of the stack, and that's where it'll find its only input parameter. And if there are multiple, it would know, like, oh, the first n slots are taking up the input parameters, like the first couple are for the first parameter if it's bigger than fits in one register or stack slot. And so it would know that. And so for right now, that's the calling convention. You put it at the bottom of the callees stack. So how should I say this? Maybe I should say input arguments. Input parameters. Right? Then there's output parameters. Input, output, which is the return values. So then there's the question of, when you're returning, where do you put the return values? Because, right, when you return, you're destroying, you're like tearing down your stack for that function. So there's one thing you can do, is place it in a register. And this is done if the return value fits in the register. So, like, the only, like, persistent register that isn't a stack slot is our accumulator register. So if you fit in whatever it is, like 4 bytes, then you can just stuff the value there. I haven't actually implemented that. I implemented what I'm about to describe, but that's an optimization you could do for the future. So what if you exceed that? It's not going to fit in a register. Well, the a natural place to put it would be right after, like, right at the top of the callers stack. So then when you pop the callees stack and you're back at the top of the caller stack, there's already the return value right there. So that's pretty much what I decided to do. Like, if I recall correctly, and now I'm starting to question myself. So I think I will just look at my implementation, right? The only complete spec is the implementation itself. So they say, so what do I do with return? So so this just sets up the stuff. So maybe I should look at actually the tests. Test. Yeah, so I'm storing the return value at the bottom of the call Lee's stack, which is then going to be the top of. So this is initially top of bars stack. So what I'm saying is that if foo returned a value, you would place it like at the bottom of the stack. And then if you would look at my return instruction here, the return instruction actually takes a value, the return bytecode, and that value is the number of stack slots to advance the stack pointer for bar. So after I return, I'm back here at the top initially, and you can see this in the VM. So I pop it and I'm at I saved wherever I was, the top of that stack, which is here. But then I advance by however much the return tells me to advance, which is here. And there's a lot of ways to do this. Like now that I think about it, maybe the caller themselves would know how much to advance. But I figured I wasn't using the instruction for return for anything else. Return before was just popping the call stack and setting all the stack pointers back in the instruction pointers. So it tells it to advance by 1. So then this becomes the new top of the stack. And why is that important? Well, because we should be able to address that place. So yeah. I'm still like thinking it out, and I realized that was like just a total jumble of thoughts, but that's sort of what I have in mind. I will definitely solidify that a little bit and hopefully write up a spec that describes it more. I mean, in reality and real hardware, the situation is a bit more complicated. In more sophisticated VMs, the situation is more complicated. So register memory is ideal. You want to use register memory as much as possible. In real hardware, you would have multiple registers in which you could store return values. There would be the convention of which registers correspond to that, like how you should interpret them, and what to do if the return value is bigger than fits in those registers. That's all like platform dependent. So I just described like a pretty simple situation. And really by next week, I hope I can make it more concrete. Yeah, so maybe it would actually be helpful if I showed you this. So yeah, so I have it right now printing the current state, which means that when I run this test, it should print out the current state. Oh, I probably would be good to keep both open. Test, yeah. So where were we? So this is the test, right? Bytecode return. So our first instruction sets the accumulator register to 0, which you can see. So this is actually a little bit confusing. So this is the next instruction, and this is the current state. So after doing that, we zero out the accumulator, right? So that means now the accumulator is 0. We didn't touch the stack. What I've done is just filled out the stack manually. This isn't actually a bytecode instruction. This is just for purposes of testing. Filled it out with like 1 and 2. So then we have this instruction arg immediate, which just means put whatever the argument of the instruction is as the call the arg on it, basically. So remember what I said, that just puts it basically at the top of the caller stack. So you can see that in the next one where there's a new stack slot and it's what we set it, which was 0. Oh yeah. So this is another thing I wanted to talk about. So the caller has to allocate the return value memory. So I think this is called caller allocated return value. Basically what this is so the caller, when it calls a function, it knows the type of the function it's calling. So it knows how much return values. Oh, okay, I remember it now. Sorry, I remember it now. So let me actually write this down. When a function when calling a function, the caller knows the callee's signature, e.g. the parameters, the return value, and input parameters. Vesper follows a caller allocated calling convention. The caller must allocate enough space at the top, of their stack for both the return values and input parameters. Both the return values and input parameters. So what does that mean? So that means if, as in the test, the function, if I pull up the bytecode, this is the function, right? All it does is add, what is it doing? It is adding so it says first load the thing at the first stack. Yeah, so it takes 2 parameters and it's just adding them. And then it's returning that. So there's 3 things that we need to allocate. The return value, the result of adding it, and then the 2 input parameters, which are the numbers we're going to add. So that's 3 slots we need to allocate. First, we allocate the return value. And we just set it to 0. It doesn't really matter what we set it to. But that comes first. We allocate that stack slot. And so this will also be the top of the callee stack frame. Then we push the 2 arguments that we're going to add, the input parameters. And so that leaves us with 3 slots when we actually do the call. So if I actually go down to the call instruction, so here, the next instruction is call. And at this point, so this is what I set up at the beginning. This is what has been set up in preparation for the call. Zeroed out, that's for the slot 2 is for the return. So actually, if you look here, so this is after we have just done the call. So this is the initial state as we enter the function. The first slot is empty. That's where we're going to put the return value, and the first and second slots are the things we want to add. And then, right before we return, what we've done is stuffed the return value in that slot we allocated, the caller allocated for it, right? And then the caller knows after we return, this is what the caller stack looks like. There's the ones that we set up initially in the return value. So that's how that works. Yeah. So that was the calling convention. It was not really explained in a lot of detail in that GitHub gist that I talked about, so I was kind of doing some guesswork there. I'll try to write out a specification, and maybe that will like elucidate it for me and for anyone interested. So yeah, this is the calling convention, and I guess by sort of abuse of notation, this will also be Myl's calling convention. But in theory, Myl doesn't need to necessarily, I guess, have that calling convention. It could just generate, if the bytecode was flexible enough, it could defer, but that's how it is for now. Okay, that went longer than I was expecting because I was kind of forgetting how I was doing that. So that's the VM, and also I hope you could see like the nice. For the sake of this, I was like, I need to finally get around to writing some better debug stuff. So I have it printing out the next instruction in the register state and the function table. And I found it useful for debugging, and it was useful just now for explaining what was going on. So what was next? So the quote, I didn't really have a lot of quotes this week. I thought of a really good one on the car ride back from work on Friday, but I didn't remember it by the time I got out of the car. But I did write down one thing that my girlfriend was telling me she saw in a video. I haven't inserted yet, so maybe we can just insert it. /quotes -help /quotes insert -help. So this was yesterday, which was 2025-03-29, and let's put that in here. I don't think that's strictly necessary. The mood was neutral, I guess. I overused that mood, to be honest. And the quote itself was this: I want to win so I can whisper in my son's ear and he will be delighted. She was watching a cooking competition video, and one of the contestants, who was Indian, said this is the reason they wanted to win. I want to win so I can whisper in my son's ear and he will be delighted. And I just thought that was so beautiful. Not only that's why he yeah, like imagine that, like wanting to win so you could share that moment of sharing your victory with your son. And he said it in such a poetic way. The reason, my hypothesis is When English isn't your first language, and I know I'm totally making that assumption that it wasn't, but when English isn't your first language, I think what happens sometimes is you have idioms in your native language. Could be idioms, could just be like the way conversations happen, the way you talk about things. And then when you translate them to English, they're not necessarily idioms in English, so they come off as, I don't want to say foreign, because I don't know how to describe it. It just sounds so refreshing, like such a unique way of phrasing something to English ears. Even though it's perfect English, I mean, yeah, I just thought that was a really beautiful quote. I want to win so I can whisper in my son's ear and he will be delighted. It shows a lot about their values. Um, so hopefully that works. And let's just double check that we can actually get it. So /quotes list date start 2025-03/20. Yeah, so I have that. Let me just commit this up. Yep, so that was the quote. What else did I want to talk about? Oh yeah, so I bought these chinos a while back. This is totally different direction. I bought these chinos a while back, and I haven't been able to wear it because they were too long, and that's really annoying because I bought 3 of them, and I bought them the size that I always do from the brand that I always buy from. The first one fit perfectly, which I expected it to because, like I said, this is the size I always order from the brand I always order from. The other 2, like, they were just too long, but they were labeled as the size that I had ordered. And, I was putting it off and I didn't really want to, um, I didn't really want to return it because I ordered it online. And I was afraid, like, if I order a smaller size, maybe then they'll actually send me the smaller size and it'll just be too small. So I kept it around thinking, like, oh, I'll go to a tailor. But I kept putting it off, and then when I finally started calling tailors, it was $20, which, okay, I mean, that's like, it's expensive, but what can you do? But the problem that really bothered me was it would take 3 weeks, and at that point, that kind of just pissed me off just enough for me to be like, you know what, it's time to learn a life skill and learn how to sew. I didn't really want to buy a whole sewing machine, so I was like, oh, I'll hand sew it. The problem is that I um there's a visible seam on the bottom of it. So I don't know if you can see like here. So this is my work. There's like a visible seam, so I couldn't use like a tape or um like a hidden thing, a hidden stitch. And like it was really annoying, like you can especially see in this leg maybe that I just can't get it to, it was just really hard to maintain a straight line and maintain the uniformity. And it took a long time. And this one, like my freaking tape measure starts counting like at 1. So like even so when you measure like that first inch, that first marker will actually be a 2. So I like marked off more than I should have. So this band is like kind of a little short now, and I had already cut the cloth. So that was annoying. And so that was one pair, which I mean, I guess it's okay. Like that one is fine. I'm not super happy about it though. And so this is the one I was working on currently. This gray pair. Unfortunately, like I started out with this black thread because that was what I had. but I think it's too visible. So I'm gonna need to buy like gray thread. It's just like super annoying. I have like half a mind to buy a sewing machine and half a mind to just buy new pants, but at this point it's kind of a sunken cost. But yeah, that was what I spent a lot of time on. I've gotten better at it. I mean, I'd not really sewn before, and already it's been pretty useful because I've been able to sew like my girlfriend's jacket. There's a hole in her jacket, some holes in her some pants. So it's a good skill to learn. Just like really annoying to like have. The problem is too like these pants I want to wear to work or wear to nice occasions. So yeah. Um, the other last thing I wanted to talk about was watches. So I've been in the market for a watch. Um, the initial one that I wanted to do was the Hamilton Murph. So I wanted like a nice watch, right? What on the Let's go to images. The Hamilton Murph. So there was initially the Murph 42 millimeters, which was a supposed to be like a homage, a close replica of the watch that was used in the Interstellar movie. And I love that movie. That movie had like a huge impact on me. Um, Definitely like a top two most impactful movie in my life. So I was like, that's like a really deep connection with with a watch. But 42 millimeters was a bit too big, so I was like thinking about this recently released 38 millimeters. Um, Side note, like one thing that I missed about the 42 millimeters is there's some Morse code on it, which is like a tribute to the role the watch plays in the movie. But it's not there in the 38 millimeters because I guess they wanted to have a differentiating factor. Um, the problem is like it looks good, but I don't know if I love like the strap. I don't really know like how good it would look on my skin, which is a little bit darker. They do have a like white version. Um, but yeah, and apparently like this is really popular. I can imagine it. Interstellar had a impact on a lot of people, but I did like the 38 millimeter size. But then like I just didn't really feel like, and like they say here, they have this sort of chain one. But I didn't really love the look of it, to be honest. And I was like, am I just buying it for its like connection to the movie? And so I was looking at a lot of other watches, and one brand that I came up time and time again that um, is Mito, which is really in the price budget that I was looking at. Um, so I know this watch by Mito. So I'm not really into like dive watches. So I think their most popular watch perhaps is like the Ocean Star, which is a dive watch. Um, but this was the first one that I saw that I was like, wow, that looks beautiful. It was this multi-four patrimony in blue. I actually like the other colors as well, but the blue is the most common one. I just think so. I think this is 42 millimeters, or no, it's 40 millimeters. So I guess the size isn't really an issue. I think 40 millimeters would be fine for me. Prefer 38, but I didn't love the strap. I didn't like it at all, to be honest. And yeah, so also now that I'm looking at it, like, is that the date window and it only has like one digit? I guess so. Um, so, but I really like the brand. Like it really good watches for that price range. I'd say under 1500, definitely under like 2500. I think is their chronograph patrimony, which is a beautiful watch, by the way. So this is the Ocean Star. See if they have a chronograph patrimony. I don't see it right off the top here. But then I saw like this one, which is this TV Big Date. and I really love it. It's supposed to evoke images. It's supposed to evoke like that 70s heritage. I think they had this design in the 70s, and in this one in particular, I guess, is evoking like the the shape of old TVs and a lot of the elements of these old TVs. And there's a really great comment on Teddy Baldassar's YouTube video by a guy who was pointing out a bunch of these details that Teddy himself didn't even mention. Right now I'm leaning towards this, especially this one. Like I love green. I love this dial. And I think the strap would look good on my skin color. So that's what I'm looking at. I mean, I would like to try it on. I don't know if like it'll be too big for me. And right now, like I'm daily driving this this G-Shock 5610, I think, which is the solar powered classic square G-Shock. I love G-Shocks. Reliable, digital. I love digital. I mean, um, yeah, I love this watch, and I actually have it on a metal bracelet that I got. I got this watch in Tokyo in the Ginza G-Shock, and they had this strap on it. They sold it with the strap, said it was like a special, unique thing from their location. But I love this watch. So this is like right now my daily driver. I mean, it doesn't really fit with all outfits though, especially like to work. So I was in the market for something that I could more like dress up. Um, I could get a dress watch. I mean, that would maybe be more versatile. Could wear it to more formal occasions too. I don't know if this would work, but someone pointed out a good point on YouTube, which is like, or Reddit, that most people are gonna be wearing Apple watches anyways if they're wearing a watch. So I mean, the fact that you're wearing anything that's not an Apple Watch is already like considered dressing up. So yeah, that's all the stuff I wanted to talk about today. Hopefully I'll get that specification out. I'm trying to build up the VM so I can start like defining a function. You might have seen that I don't have much opcodes, but I have the opcodes for defining functions because that's like a good synchronization point, I think, between the front end and the VM and the back end. So that's what I'm working towards. Yeah. So we'll see what next week brings.